many of us have had experiences at some time or another that might be characterized as beginner's luck. Paulo, I don't know how to pronounce his name, Coelho, the author of the bestseller, The Alchemist, suggested in his book that every search begins with beginner's luck and ends with the victors being severely tested. And many of us, I think, have had experiences where when we try something new for the first time, for whatever reason, it seems to work remarkably well. And then as we try to do it further, it becomes more and more difficult. I've personally experienced this, and this will be part of my talk. I've experienced this in many realms of my own research, but also I think even it seems as if there is at least the illusion that this happens in all realms of life. When we go to a place for the first time, we try a new activity for the first time, somehow it seems to really just open up to us, and then as we keep working at it, it's not as easy as it first appeared. This basic idea of beginner's luck seems to apply in research as well. It certainly has been my experience. It seems to be a ubiquitous aspect of research that are associated with a level of success that is then subsequently hard to replicate. And I've observed this in a variety of different ways, but it was first noted by Rhine when he was attempting to characterize the drop in performance of one of his star clairvoyant participants who showed absolutely amazing ability to anticipate the nature of cards, and then over time gradually diminished in his capacity to do this. And this basic notion of the decline effect has been recognized first and foremost in the psi literature. Dean Radin, in his book Entangled Minds, refers to it, saying, a frequent observation in psi research is that when a new experiment is first conducted, the outcomes are strikingly successful. Then, as others try to replicate the effects, they begin to fade. And indeed, and notably, and this may be part of the secret of his success, Dean has indicated that he never tries to totally replicate prior findings. He's always, changing the paradigm in particular ways. And this may be one of the critical secrets to his success and to others who have had a success in this field, but it also may be one of the critical sources of why it's been so hard to get psi effects established, because when other people try to replicate the paradigms exactly, they don't get the same degree of success as the original studies did. What I want to do today is to talk about examples of the decline effect, both in my personal research and then also in other areas of psi research, in other areas of traditional, conventional areas of research, and then consider some of the different possible explanations that may be driving it. So let me begin with my own personal experiences with the decline effect. I started off as a graduate student investigating a phenomenon that I came to call verbal overshadowing. And verbal overshadowing is the finding that the paradigm worked as follows. People would view, say, a videotape of a bank robbery, and then one group of participants would be asked to describe in as much detail as possible the appearance of the face. And another group of individuals would engage in an unrelated activity, and then they were given a lineup. Now, standard theories would suggest that engaging in verbal description would be a form of verbal rehearsal, that this should be helpful, and that the people who describe the face should be at least as good, if not better, than the people who didn't. But we found was a rather substantial negative effect, such that when people describe the face, they're actually less good at recognizing it than those individuals who engage in an unrelated activity. I replicated this effect 5 times in the original set of studies that were published in Cognitive Psychology, and without difficulty. It was very easy to get the effect at that time. Subsequently, as I continued to try to replicate this effect, I found increasing difficulty. I got it sometimes, other times not. The effects got much smaller. I have a whole, I have boxes of failed versions of this experiment, and it was really very disheartening. What I discovered was, rather than trying to replicate verbal overshadowing effect with faces, my best bet was to always try new areas. And so we did it in a number of different domains. We did it with color. We did it with tastes and shapes and various other things like that. And what we found in these different areas is the first or second time we get the effect, but then as we tried to replicate that, it would go away. So we got it with music, but that failed to replicate it. We got it with color, but that failed to replicate. I don't have it listed here. We got it with maps, describing a map, and then that failed to replicate. So all these different cases where the first time we did an experiment, or maybe the second, we'd get the effect, and then after that, the effect would get smaller. We also observed this not only with respect to nonverbal memories, but also with respect to other sort of variations on the paradigm. So in one series of studies, these were 4 experiments published in JP General, we had people think out loud while trying to solve insight problems or engage in silent solving. So again, the idea is that verbalization is somehow messing them up. We got the effect quite robustly in those first series of 4 studies, but then subsequently increasingly had difficulty replicating that effect. In another study, we used a paradigm known as implicit learning, in which individuals are given artificial grammars and they have to learn new examples. Again, we found that when people thought out loud, it disrupted performance. Subsequent replications failed to get that effect. Another paradigm was analogical retrieval, where we had people think out loud while trying to remember what analogies were to stories that they'd heard before. Worked great at first and then dissipated. So I've observed this fading effect just countless times in my mainstream research. I'm just curious, how many people in the audience who are researchers have also experienced decline effects? Let's just get a raise of hands here. Okay, so as you can see, this is how many people, just to get a sense, how many people have gotten effects and they've never seen decline effects? Okay, so you can see the majority of people who do research have experienced these decline effects. It's important to get your base rate here. So this seems to be, it's not just that sometimes some people publish experiments and then other people don't. The very same researcher can get the effect and then watch it dwindle. So now, I've also been doing parapsychology research. It's somewhat unusual for somebody who's been doing the mainstream research to the degree that I have to be doing this, and I am totally aware of the fact that this does make me vulnerable to criticism among my mainstream colleagues, but I still am persuaded that the evidence is sufficiently compelling that it's worth pursuing. So I've been doing this. I've looked at precognition in 2 different domains. What I'd like to do is to tell you about both of those paradigms and then show you, in both cases, the decline effect. The first paradigm, by the way, both of these paradigms are closely related to a series of studies that just came out in Journal of JPSP, one of the flagship journal in social psychology by Daryl Bem. Many of you probably are familiar with that study. I was a reviewer on that for that study. And the basic insight of all those studies is that you basically have the independent variable happening after the dependent variable. And so in his case, there was mere exposure happening after the people's judgments of the arousing quality of the effect and of the image. But we did several variations on this. One of them was temporally reverse perceptual priming. So there's been a lot of research which shows that if you view an image and then subsequently flash the image very briefly, that you can recognize the image more with a shorter interval if you'd seen it before. There seems to be increased perceptual fluency to the image, and as a result, it takes less subsequent exposure to be able to identify it. This is a phenomenon known as perceptual priming. And so what we did is just to try to reverse the paradigm. Rather than showing people the image first and then having them make an identification from a briefly presented stimulus second, we did it the other way around. We showed them the briefly presented stimulus first and asked them to make an identification, and then subsequently either presented it again or not. So the way the paradigm worked was as follows. Individuals viewed a fixation. There was a noise mask. I'll show you what that means in a moment. Then there was a briefly flashed image. The noise mask followed, and they had to indicate whether they knew what was presented. And then the prime happened. After they'd already made the judgment, either the image was repeated or was followed by a blank screen. So there's the fixation point, the noise mask. Was an image presented, yes or no? And then in this case, an image is presented. So that would be an example of a case in which there was a prime. Here's another case. Was an image presented, yes or no? And there's the blank screen. So what we found is that when individuals had made the judgment and the image was followed by a prime, they were significantly more likely to say that they knew what the image was than if it was followed, if it was not primed. And we did this a number of different times. This is basically various different permutations on the basic paradigm. We got the effect numerous times significantly, but here's the decline effect. What you can see is this is the magnitude of the prime effect, and this is the experiment number. And as you can see, the effect size dwindled markedly with subsequent experiments. If you look at the overall linear effect that's here, we get a p-value at the 0.00017 level of significance. If you just cut it off here, these are with smaller n's. This is when we started running larger groups. Even when we just start from experiments 7 to 19, we still get a significant decline effect. So we observed a very robust decline effect in this series of studies. We ran over 2,000 participants, so we really just hammered this experiment to the ground. It really just washed it out completely eventually. So the conclusions from this: overall, the effect remained significant, but we observed this massive decline in significance. The earlier studies may have had an advantage of smaller n, and this is always a concern that you can have in these situations, when you have smaller n, it's easier to get spurious results. But even when we looked at the later studies that had larger n, we still get a significant decline effect. So this is one compelling example, I think, of a decline effect in my own lab. Let me introduce you to another paradigm. This is a paradigm that was developed by my postdoc, Michael Franklin, who's been working in my lab for 3 years now. My hat goes off to him. He got his Ph.D. at University of Michigan and could have gotten lots of really good mainstream postdocs that would not have threatened his career, but rather was so committed to pursuing psi research that he came to join my lab and work on this paradigm. I'm happy to also say that I've also getting him doing mainstream research, so I'm hoping that he's not necessarily destroyed his career by going in this direction. But it is a real frustration, of course, that one has to really advise junior scientists against doing this kind of research because of the huge stigma that, as you know, is associated with this work. So anyway, my hat goes off to him for having the guts to pursue this, knowing the risks that he's taking. So this paradigm is a retrocausal practice paradigm. So imagine that you gave individuals practice making a particular kind of perceptual identification, and then you gave them 2 different perceptual identification tasks, one with the items they had practiced with and another that they had never seen before. You'd be able to tell, based on the performance at time 2, which ones they had practiced with at time 1, because their performance should be different. And so that's basically the idea here, except it's reversed. In this case, individuals make discriminations with 2 sets of stimuli initially, and then subsequently they get additional practice with just one or the other set of stimuli. The stimuli that he used are these nonverbal shapes, and so people are basically asked to respond to either one kind of shape or another type of shape. So it's a basic perceptual discrimination task. And the pattern of results is a little bit quirky. It's not just that practice with the shape that you've seen before leads to improved performance, but rather what he found was a significant priming effect, such that practice with shape A led to superior performance with shape A, but it also practiced with a shape A also led to a superior performance with shape B. So for some reason, the pattern of results is a little peculiar, but the basic point is that he's finding is that practice at time 2 influenced performance at time 1. That's the take-home message that this paradigm revealed. And he found that pattern in both the original study and in a number of different replications. Now, he presented this work at the major brown bag at our department, and people were sure, there must be something about the random assignment that maybe because the computer was doing the assignment, even if it was using a random number generator that was based on physics properties, there must be a problem there. And so what he did, instead of using a random number generator based on the computer, was instead to use the outcome of a off-site roulette wheel. So if you think about this, this is very promising. So in phase 1, individuals are given practice with, they work with both shape A and shape B, okay? And then at time 2, there is a roulette wheel spin which determines which shape they're going to, which set of shapes they're going to get additional practice with. And so if the ball lands on red, they get practice with shape A, and if the ball lands on black, they get practice with shape B. Now, the nice thing about this is what this means is that you should be able to predict from their performance on phase 1 what the roulette wheel is going to spin to. If it's going to, if their performance suggests that that there is more likely that they are going to have practice with shape A, then that means the roulette wheel is going to assign them based on red. And if it looks more like B, it suggests that the roulette wheel is going to be associated with black. So the exciting thing about this paradigm, basically, is we are now predicting the outcome of a off-site roulette wheel. Now, money speaks, right? So if this paradigm were to hold up, we wouldn't need to get grant money, right? We could just make our money for the research, winning money off of a roulette wheel. So this is a very exciting procedure, and obviously, skeptics are going to have a hard time going, well, yes, I know you made millions of dollars, but it was confounded, right? So clearly, this is a very, very compelling kind of paradigm for persuading people that there's really something there, because money speaks. The basic finding, and this is what's basically happening, is our ability to predict, based on performance at time 1, whether or not the roulette wheel is going to assign people to one condition or the other. And the findings with 153 participants, the performance, our ability to predict the spin of the roulette wheel was 55.55, where chance is 0.486, and the reason chance is not 50 is because this is a gambling site, and so there's a 1 green where you don't win. So it's 6.9 above chance, which is significant, 0.10 with the two-tailed test, so marginally significant. Importantly, as you can see here, it's better to see it here, this is the magnitude of the effect over groups of 10 subjects. And basically what we got was very significant in the first quartile and then less significant subsequently. And if you look at the overall decline effect, it's R negative 0.45, P equals 0.05. So at the moment, this effect seems to also have declined. Now, Michael and I have somewhat different perspectives on this. He's hoping that the effect, this is just a lag and that it will come back, and I'm seeing this more as there's the decline effect again. But there seems to be a number of things that we can conclude from this experiment. The first is that overall effective retrocausal effect practice remains significant. It's important to keep in mind that this is just one of a whole series of over 900 participants that Michael's run in this paradigm, and overall we still have a significant retrocausal practice effect. Secondly, this is a really elegant paradigm, and I would encourage people to think about developing their paradigms in this way, in that the obvious significance of such a finding. If you can find a finding that can make money, then that's really going to persuade skeptics in a way that little else could. And then finally, relevant to the current discussion here, the decline effect observed was significant. So again, we are seeing this haunting decline effect. All right. So it turns out the decline effects are not just limited. No, sorry, before I get into that. The decline effect has been shown up in a number of meta-analyses in various areas of psi research. So this is a meta-analysis reported by Dick Bierman in 2001 on dice throwing, showing a significant decline in people's ability to get dice to produce the outcomes that they were trying to get. Here is a similar decline effect in the Gansfeld procedure. Presumably everyone here knows the Gansfeld procedure is basically a remote, it's a telepathy procedure where individuals are able to know what the sender is sending with half ping pong balls over their eyes to get sort of a better sense of the image that's being sent. Again, a significant decline effect. But interestingly, there seems to be what may be a decline. So here they've demonstrated a decline effect, and this raises this really interesting thing. If you demonstrate empirically the decline effect, does that replicate? Well, it turns out that it seems that even the decline effect is subject to the decline effect. So here is a recent meta-analysis by Storm et al. And you can see right here the sort of the peak of the decline effect is right, in this Bierman meta-analysis, and now it comes back, sort of evening things out. So it may be my sort of secret hope here is that by really going after the decline effect, I can get rid of it once and for all. And by the way, this is not the only place where you get this decline and return. It's also been found in the RNG paradigm. Again, you see this decline effect and then a return. Oftentimes, the return is not quite as strong as it never seems to quite get back to its original place. But there does seem to be this peculiar decline in the decline effect. All right. So conclusions from the meta-analysis of psi research. The decline effect is observed in a number of domains. After decline, a return is observed in the longest studied domains. And this plausibly could be a decline in the decline effect. Now, it turns out that this is not, as already anticipated by my discussions of my own research, the only place where decline effects have been observed. They've also been observed in a number of different domains. This is a meta-analysis of drug treatments of schizophrenia. Actually, my mother, oddly enough, was an author on this meta-analysis, and I just was at the house one day and I saw this, why do drug effects decline? I was like, oh my God, it's there too. And so they have this really powerful decline effect of 0.55 in this. Many of you may know that there was an article that was described by Jonah Lehrer, or article written by Jonah Lehrer in the New Yorker. That got a lot of press. I got a lot of emails as a result of that. One of the emails I got was from Robert Kaplan, who is notably now the NIMH Associate Director for Behavioral and Social Sciences, so a major player in mainstream science. And he sent me several meta-analyses demonstrating decline effects in a variety of different drug research domains, including Prevestin, which is a treatment for cholesterol, Timolol, which is a beta blocker, and also latanoprost, which is a treatment of glaucoma. I'm delighted to say that Dr. Kaplan is working on getting an invitation for me to speak at the NIH. So there's this hope that the decline effect may be sort of an entry point for getting a finding that was originally discovered in parapsychology really into the mainstream. This decline effect has also been reported in meta-analyses in biology. There's a meta-analysis by Jenyans and Moeller, and they say in which they found there was a small but significant decline effect in size with the year of publication, and the effective year of publication remained even after we controlled for sampling effort, similar to my study where we had smaller n at first and larger later on. Same thing is observed in this case, and these are just the numbers that bear that out. So the conclusions from the decline effect in mainstream science: there's been decline effects observed in a variety of domains, including antipsychotics, cholesterol-lowering drugs, beta blockers, treatment of glaucoma, and in a variety of different domains of biology. This is not just limited to psi research, although clearly there's some constraint here. I mean, balls, when you drop them, they fall at exactly the same rate every time. So there's a lot that we don't understand about what the specific parameters are for where decline effects are observed and where they're not. All right. Now let me take a breath, step back for a moment, and talk about possible accounts of the decline effect. It's really critical to emphasize that there are a number of very compelling conventional accounts of decline effects. And before we get all carried away with the psi kinds of accounts, it's really very careful to acknowledge conventional accounts, think about them carefully, and consider to what degree they may be playing. The first one, most obviously, is regression to the mean. That is, every now and then when you run studies, sometimes you're going to get the actual variance associated with the manipulation, and there's also going to be noise variance. And when the noise variance goes in the same direction as the actual variance that you're looking for, that's going to lead to a distortion, a distorted estimate of the effect size. And so it may be that if you get lucky and get this distortion, that's going to lead you to overestimate the effect size initially. It's a very compelling explanation. One thing it doesn't really explain is why the decline effect tends to have this linear pattern. Regression to the mean would predict that you should get a big effect, and then it should just vary around the mean thereafter. So that's the problem with that one. Definitely can account for some findings, but not necessarily all of them. Another one, I think this is a very, very elegant explanation. It was suggested to me by my colleague Dan Smilek at University of Waterloo. It may be that when we run studies, there are a number of aspects to the paradigm that we have made explicit, that we know are important. But there are other aspects of the paradigm that may be important, but we haven't recognized them as such. So when we replicate the experiment, we always make sure to do the parts that we know are important, but there are all of these other parts, that what we thought are superfluous, that actually turn out to be critical. Because we don't recognize them as being critical, as we replicate, they gradually become less included, and so the effect size dissipates because we're not recognizing some of the critical variables. This makes a lot of sense, but it raises the question, why do we get so lucky and get it all right at first and then go in the wrong direction? Shouldn't it also happen that we get it wrong at first and then get better as time goes on? So it makes sense, but this has this sort of peculiar reliance on luck. Another possibility is just that we refine the procedure, that there are confounds in the procedures initially, but that then as we refine those procedures, we get rid of the confounds, and that makes the effect go away. Well, that makes sense, but shouldn't we also be refining procedures and get stronger? We should understand the phenomena better and actually be able to get the effects better. So this makes sense, but it's a little bit confusing as to why it would only go in one direction. And lastly, the possibility of publication bias, that initially the only way you can get something published is if you get a large effect and if it's very sort of straightforward, but then as people are attempting to replicate it or looking at various different parameters, there may not be the same onus to have to get such a large effect size. This also makes a lot of sense. This has been the explanation that Virginians and colleagues suggested, but it doesn't explain my own experience. There's no publication bias that produced that linear decline in the however many 15 precognition studies. So that alone doesn't explain it all. Now, it's possible, and I would have to say, when I put on my traditional, I would have to say that the most parsimonious explanation is it's some combination of all of these, that any one of these alone doesn't do it, but when you combine them all in just the right way, that's sufficient to account for the decline effect. And I think that is the explanation that needs to be beat. That said, I also think, and I've talked about this, I've stuck my neck out and talked about this publicly and even in an article in Nature and in my interview with Jonah Lehrer, I think it's also appropriate to consider, if not yet to subscribe, to some non-conventional accounts of the decline effect. And so here I'm going to sort of let my hair down a little bit and talk about what might be some things going on here. Again, I want to emphasize that I see these as incredibly speculative. One possibility is that there's some sort of Heisenbergian process going on here, that somehow in the process of observation of scientific phenomena, we change the phenomena. So it's typically the way Heisenberg and the Copenhagen account goes, and mind you, this is no longer the mostly accepted version. The act of observation changes at the local level the particular way in which collapses the probability cloud and influences the particular manner in which, say, an electron is located. Here the idea is that it's not influencing the specific location of a particular event or occurrence of a particular event, but rather the nature of the rules of science more generally. So this sort of assumes, it challenges what is an absolutely fundamental premise of current science, which is that the laws of nature, whatever they are, discovered or undiscovered, are immutable. And this basically says, no, the process of observation may actually change the principles of science. Now, this is very radical, but it's also important to emphasize that I'm not the only one who suggested this. Physicists have also acknowledged that the premise that the laws of reality are immutable is an assumption and cannot be taken as necessarily dogma. Some possible things that might contribute to this way in which the act of observation has its effect. One possibility is something that I refer to as cosmic habituation, The idea is that when you first study something in a novel way, it's entirely novel. It's never been observed before. And so its novelty is, as we know, consciousness, one of the critical aspects of consciousness is very sensitive to novel things. When I first put my finger on my arm, I feel it. After a while, it habituates. In some manner, there may be some kind of habituation that's happening, perhaps in some sort of collective consciousness when individuals make an observation. At first, it is novel to reality, and then as it becomes repeated, it becomes less and less novel as some sort of habituation. In some sense, this is sort of the opposite of morphic resonance. Morphic resonance is the idea that once you put something out there, it expands. Here, the notion is that once you put something out there, it declines. When I first mentioned this to Rupert Sheldrake, he was rather skeptical about it. But after the New Yorker, he contacted me and said that, in fact, he'd been experiencing decline effects in a number of his paradigms as well. So he's become a little bit more open to the possibility that there could be a flip side to morphic resonance, which would be something along the lines of cosmic habituation. A second one, and again, I want to emphasize that these are not explanations. These are just sort of like possible things that this decline effect reminds me of, this almost metaphorical, imagine that you have a telescope and you point it at a distant object and it's not in focus. Initially, that distant object is going to be blurry, and when it's blurry, it's going to occlude more visual angle. It's going to be larger. As you bring it into focus, it'll actually get smaller, right? It'll be sharper but smaller. It may be that when we do scientific research, it's kind of the equivalent of pointing the metaphorical telescope at the phenomena. When you first look at it, the phenomena is sort of more fuzzy and distributed, but then as you do more research, it becomes more narrow, which means that areas that used to be occluded, the object is no longer there. And so it may be that there is some sort of way in which the act of observation, by becoming more precise, actually areas that where the effect was once is no longer there. This also suggests that if you really get the bullseye, that it'll be there even in spades. So it sort of gives hope that it's just a matter of getting it exactly right. But the idea is that typically when we're sort of throwing darts at things, we're just getting right on the periphery and not really narrowing it down to its absolute fundamental locus. And then the third thing, and this is, again, not even really an explanation, but it's just sort of an intuition about what's going on here, is that beginner's luck, there may be something about this notion of beginner's luck that's somehow intrinsic in the way that reality is structured, that when we do things the first time, they afford greater opportunity than later on. Who knows why that would be, but it just seems possible that beginner's luck is an intrinsic aspect of reality. That certainly is the claim that Kolo made in the opening quote. So in terms of future directions, first, it suggests that novel paradigms should do better than ones that are strict replications. And secondly, I didn't really have time to go into this, one of the things that I've really been pushing hard for is we need to have an open source data repository where people log their experiments ahead of time and report the outcome regardless of results afterwards. The problem in the current system is that we don't know how to fit the positive results with respect to all the larger negative results that are out there and are not being reported. Scientists need to be required to make all of their research available and not just that which they've been able to spin for acceptance into the scientific record. It's only by knowing the full set of data that we'll be able to understand how the positive results that we get relate to the negative results that may also be out there. So my final thoughts are two. The first is that ironically, it may be that the domain of investigation that has been most frequently accused of a lack of rigor, psi research, will be the impetus for reining in the sloppy practices of science as a whole. And I think this is really a possibility. And secondly, I suspect that the best evidence for psi may not be found at the individual experimental level, but rather at the meta level, that when we set up this giant repository, we will then be able to actually see these anomalies, and they won't be able to be dismissed. So it really may be the meta level where we're really going to find the best evidence for psi. Thank you very much.
I think you're going to get a long line here. I've done healing research for a number of decades now, and I suffer badly from a lack of a decline effect. And this has bugged me. I mean, quite frankly, it sounds silly, but it's actually bugged me. So at this point, I've done 12 mice experiments on cancer that has 100% fatality, and I don't have any decline effect at all. In the beginning of your talk, you were talking about changing things like color and this, and so you change something and then it goes down, you change something, it goes down. The flip side that you're making me consider is that the most number of studies I've ever done in one place is 3. I've actually done it in 6 places. I'm wondering if changing the actual place might mitigate somehow the decline effect.
Well, that's interesting. I've found that I can't replicate certain effects, but then when other people try them for the first time, sometimes they can get it, and then they suffer their own local decline effect. So there may be, when all the dust settles, some sort of peculiar rules about what the sort of geography, that you get a local decline effect and then a global decline effect, and that's certainly possible. We just need to do a lot more research in the parameters to be able to establish those kind of rules.
I think the problem is that in science, the ideal is that you replicate an experiment perfectly, but I have a little statement I wrote, so I'm going to have to read it here. No experiment is perfectly isolated and perfectly replicable because the universe changes around the experiment no matter how hard we try to objectively isolate the experiment from the universe. Now, we've all been saying for the past few days that all things are connected when it comes to side effects. Then this change in the universe should be taken into account regarding testing any side effects. In other words, what I'm suggesting is that there's a certain half-life just due to the normal change in the universe that we see as time, and this should be taken into account into all psi experiments. It is the idea that the universe is changing, and in a sense, what we're trying to do with psi experiments, we're trying to bend the universe around any individual experiment, but the universe is changing around the experiment at the same time, and we have to take this into account. And perhaps people who have psychics and such that have success after success, if it's possible, with side effects, are somehow subconsciously taking this change in the universe into effect from time to time.
Well, I think that's certainly something to consider. If you imagine that the universe is sort of gradually changing, and that changes in the universe are associated with reduction in decline effects, then that could also explain why you see these recovery effects. That it may be that over time, the experiment is, even though you're seemingly doing the same experiment, you're not really, and that's how it is that recovery may take place. That certainly could be the case. I wish the universe would change faster so that my decline effects didn't happen so quickly.
It would be slower, right. Picking those faster, I wish we could ask the questions faster so we could get more answers from our...
Yeah, well, there are 3 factors that could be playing on the size effect that comes first quite high and then comes down. One could be the real size effect, you might say. And the other could be 2 possible augmentations of that size effect. And 2 of the candidates for those augmentations are the experimenter effect and the universe. It could be that the experimenter is not the same experimenter, and that whatever constitutes the experimenter effect it itself has declined. Just the enthusiasm or the surprise and the staking your whole career on it. But the universe, and a lot of the papers that we've been hearing imply that there's a kind of a cooperation between the universe and what we perceive or can do. And there's no reason why, whatever the universe refers to, why it should give a damn after a while to be at your service as an experimenter to turn you in the right direction. If you've turned in the right direction, fine. If you haven't, fine. It's just going to poop out and go augment somebody else's research.
Yeah. I can't speak for I cannot speak for the universe, that's for sure. But what I can say is that you mentioned a really important interpretation of the decline effect that I didn't mention, and this is one that I know Dean favors and Daryl Bem, which is the idea that it's driven by the enthusiasm of the experimenter, that when experimenters first start running their studies that they're really gung-ho, and somehow that gets communicated to the participant. I just have to emphasize in there, I mean, some of these studies, we run them, there's very little interaction with the experimenter. They're basically interacting just with the computer, and we still see the decline effect. So while I think that the enthusiasm of the experimenter may be part of it, I'm not persuaded that that alone could explain it.
You've largely just answered my question. We've seen all over the place decline effects where the interaction between the experimenter and the experiment, even if it's just a computer running. I don't know if you saw my talk last night where we see this, huge decline effect in a pure computer experiment. But we really can connect it with our own enthusiasm. And that does seem to be the most parsimonious answer to the decline effect. It does mean that all of these experiments involve psi, but that's not a far reach from what we've been seeing. So I'm surprised that that's not your primary thought.
Well, I mean, I would say it's hard for me to believe. Let me just emphasize. I am open to all possible explanations. There are two different versions of the enthusiasm account. One is a conventional account, which is just that the participant themselves is picking up directly on an interaction with the researcher, and that's having its effect. The other possibility is that somehow the researcher's enthusiasm is making its way into the ether, and that's driving the effect. That second possibility is certainly there. It's not obvious to me that researchers' enthusiasm for effects should necessarily show a decline. I've seen my postdoc Michael Franklin, the longer that he's been involved in this, he's invested more. So you could easily make the case that the longer you've been involved in research and you've started presenting and stuff, you should be more excited about it because you've really put your name on it. So it's a peculiar kind of enthusiasm that dwindles as you've staked more of your reputation on it.
With that view in mind, I think the word is intent. It's not necessarily enthusiasm. It's focused intent, and how rooted we are in a sense that there is only this reality that we're experimenting with. There have been a whole bunch of researchers and a whole bunch of guys. One that comes to mind is a very strong PK guy named Michael Hutchison. Had an effect named after him, Hutchison effect. He could do certain things with his machines that nobody else could. And this just, if you think about it, what is the nature of the reality that you're working in? And then you have some researchers like William Tiller and this earlier speaker, Yuri Kahn, talk about conditioning space and altering the space that you're working in so that it no longer behaves the way, quote, normal, whatever that is, space behaves. And so I'd say the focus of intent by the researcher can flag. The enthusiasm may be there, but there is a real, and there are tons of shamanic and other traditions where this is a key to manifesting the reality that you really want. So I know that's fairly far out, but
well, I mean this is the right group for that. I just want to say that this notion of sort of that's getting close to the notion of habituation, which is the sort of a variation on the cosmic thing. But I think you're right. It could well be driven just by the individual as opposed to by some more global kind of habituation.
So since there are, since arbitrary random processes can have arbitrarily long, what you might consider hits, right? Is there an anti-symmetric effect here? So then in the sense that if you had an experiment that was negative at first, it's more likely that you're not going to consider it again. So that file draw effect seems to maybe make sense to me that there is no decline effect and that the total sample space of experiments isn't robust.
Absolutely. That is one of the major explanations to beat, and that's why we need to have this open database repository, because according to that interpretation, there should be a huge number of failed first experiments that are not pursued. And so what you really need to do is to look at the frequency with which initial experiments are failing versus succeeding, and you could do Monte Carlo simulations to see whether or not that would be sufficient to produce the magnitude of the decline effects that we get. But the only way we can do that is by situating the positive results in the context of all the negative results that may or may not be out there.
Thank you. He pretty much stole my thunder. My question was going to be, you can only have a decline effect if you already had a positive correlation to begin with. has anyone conducted experiments where they did not have a positive or negative correlation, continue that experiment to see if you had an ascending
Absolutely.
and then a declining?
Right. This is another approach that I think would be very useful. What I think would be a great idea, so let me put this out here right now, is to come up with 25 experiments that have not been run, that are novel, that ought to maybe work given what we know but have not been done, and then get the group of researchers to commit to running each one of those experiments 10 times, regardless of whether or not they worked the first time, and then look to see the pattern of significance. The decline effect account would predict that you should be more likely to get positive results in the first trial than the 5th trial, but that is exactly the kind of paradigm that's required, and it requires people to carry on doing the studies repeatedly, even when they don't get the effects initially. So
Exactly,
thank you.
yeah.
That's
But
exactly what
beginner's
needs to
luck
be
would
done.
be thrown out the window.
Exactly.
You presented it somewhat facetiously and the audience laughed, but I am actually rather charmed by your proposal that the decline effect could actually decline. Do you have any estimate for how big a research effort on the decline effect itself would be needed in order to run it into the ground so that we don't need to worry about it anymore?
Right. I was only half facetiously. I also think that the best hope of getting rid of the decline effect is by studying it. I have no idea how much effort that would require, but that's certainly where some of my energy is going.
Hi, I was wondering if you could talk a little bit more about sort of the local versus global decline effects and what you know about that. And then secondly, kind of in conjunction, if something about having information about one's own experiments drives the decline effect in some way, could that not be a problem for this sort of metadata idea, where when we now have all the information available about everybody's possible experiments, that somehow it's harder to have your own local version of a decline effect?
Yeah. Most of that is just needs to be studied. I mean, I think we really need to go, I think we need to admit that the decline effect is an area that deserves studying, and then look at it very systematically, both at the local and at the global level. I also think it's a very intriguing possibility. What triggers the decline effect? Is it the running of the experiment, or is it the analyzing of the data? And what I think is quite, if we're going to go with some of the non-conventional accounts, you know, the sort of Heisenberg thing, what may really drive the effect is not the point at which it's collected, but the point at which the experimenter looks at the results. And that's the kind of thing you could also systematically vary. You know, when do they peak? And there's this possibility that, I mean, you want to be really, it may be that the peaking is really the problem here. So, you know, really collect a lot of N before you peak, because once you peak, that's when the effect starts going down. Those kinds of things, systematically controlling when the peak is done and who's peaking, how many people are peaking, might be one way of finding some of the psi effect at the meta level.
Well, as somebody who's quite familiar, painfully familiar with decline effects, we studied it for many years over many different experiments. It's quite robust.
Oh, dear.
And it does seem to occur at local as well as meta levels. And incidentally, we also looked at experiments that had no effect, and there was no decline. They were pretty level. One thing that I think is worth mentioning is the oscillations one sees in the effect. It's very seldom a direct one-to-one decline. What you're seeing is a trend superimposed on fluctuations that you would expect in a random process. And they do seem to recover after a certain period of time. But this has led us to suspect, going back to our friend Werner Heisenberg, that maybe there's something in here that relates to the concept of uncertainty. In fact, we have a paper that we called Information and Uncertainty. And it may be that since we are dealing with fundamentally probabilistic processes, which of course we are whenever we're doing statistical analysis, that the more we do, and the more data we collect, the more the uncertainty is reduced. And the uncertainty may be an inherently important component of driving these effects. So as you reduce the uncertainty and attempt to enhance the noise, the signal relative to the noise, you may actually be driving out the source of the effect you're looking for. And it may just be that you get to some point in the decline where you say, enough of this. Maybe I was just messing with my own head and there's nothing there. And you go back into a state of high uncertainty and my God, there it is again. But I think this idea of probability and uncertainty is worth looking at, because in informational systems that have statistical bases, this could be a very fundamental issue, and it could help us understand the process better.
Yeah.
But I'm awfully glad to hear we're not the only ones who's
that sounds right to me. The uncertainty feels like it may play a role, and certainly there's a sense in which one gets at least a false sense of certainty as one keeps seeing positive results.
Well, one thing for certain, we have to move on to the next speaker, so thank you, Jonathan.